Thanks everyone for joining. As Jen said, my name is Sergio Del Amo. Happy Pi Day, everyone. We searched the perfect excuse to talk about MQTT, and celebrating Pi Day was a good one. Let me share my screen. So what I wanted to show you is so I'm not an MQTT expert myself, but I'm gonna explain you a little bit what MQTT is and what the Micronaut MQTT module is, and the way I'm gonna show that to you is with a demo. We have a guide which covers the same demo content as we're gonna be demonstrating today. So hopefully that's of interest to anyone. So let me make the slides bigger and get started. If I manage to move the Zoom window around. I will be keeping an eye on the Q&A. I saw Saki's already there, and the chat as well. So I have two monitors. I moved the Q&A to another monitor. And so as I said, happy Pi Day. We thought about what things you may want to use. So what Micronaut modules you may want to use in a Raspberry Pi device. And MQTT seemed like the perfect fit because you often will use such a device with in combination with sensors and things like that, which could send MQTT messages, and also it also like shows that Micronaut is well suited to be in environments with low resources. So what I'm gonna show you is I'm gonna be running an MQTT broker here on my Mac, and I'm gonna be running a Micronaut CLI application to emit MQTT messages, and I'm gonna be running a Micronaut messaging application to subscribe to those messages. But and you could generate also Graalvm native images of both the CLI and the messaging application. I could be running those applications in a Raspberry device, no problem. And also the Mosquito MQTT broker runs fine on a Raspberry Pi. So if you want to, after this webinar, you are inspired to try and play a bit with MQTT and your Raspberry device, please do, because that's a perfect environment to do that. And the MQTT, the acronym stands for Message Queue Telemetry Transport. This is a quote from the official MQTT documentation. So it says MQTT is a client-server publish subscriber messages transport protocol. It's lightweight, open, simple, and designed so as to be easy to implement. This characteristic make it ideal for use in many situations, including constrained environments such as for communication in machine-to-machine and Internet of Things context, where a small code footprint is required, and or network bandwidth at a premium. A brief history about MQTT. So this was invented by Arlen Neiper and Dr. Andy Stanford Clark in 1999. So as you see, it's quite a modern protocol. It was made royalty-free in 2010. And in 2012, Mosquito, which is an MQTT broker, was I think was made open source or public, and this had a big impact in the adoption on MQTT. In 2014, MQTT 3.1 spec was released, and chances are, if you are working already with MQTT, you probably are working with MQTT 311. In 2018, MQTT 5 was released, which is backward compatible to MQTT 3 and adds extra features. What are the MQTT characteristics? MQTT is binary, it's efficient, bidirectional, data agnostic. You can send anything. I'm gonna be sending, emulating, like if I was sending like a temperature sensor value, but you could send a JSON payload if you want. It's scalable, it's built for push communication, and is suitable for constrained devices. And it has become more or less the de facto standard for IoT. It's the de facto IoT message protocol. It's built on top of TCP, so it will be IP, TCP, and MQTT. And that has many advantages of being on top of TCP. It has a minimal overhead. And it is one important characteristic is thought. The idea is to have a way of having reliable communication over channels that we know are going to be unreliable. So it deals well with unreliable channels, and that's probably one of the reasons why it has become such a de facto standard for IoT. Traditionally, in many Micronaut applications, we used a client and server pattern where you have like a client that does a request and the server generates a response, either a JSON payload or an HTML site or whatever. When we talk with MQTT, we are talking about a publish subscribe pattern. So typically you'll have what we call MQTT clients. So in this diagram, you see there on the left, what we could say is a temperature sensor, which is going to publish. You're going to publish into an MQTT broker, and you're going to have clients. I have here, for example, a client illustrated on the right with a computer image, which is subscribing to a particular topic. And you can have clients such as the one shown on the bottom, which publish and subscribe both. So it is bidirectional. It is the publish and subscribe characteristics of this pattern is space decoupled. You can have sensors which are published into the same MQTT broker, which are in completely different spaces. It's time decoupled. You can have you can publish and consume the event in a different time, and it's not synchronized. So you can it has synchronization decoupling as well. One of the issues here is that MQTT becomes the single point of failure, and the solution of the industry here is typically you have like MQTT brokers with clustering capabilities. So if you go like to the route of the Hive HQ or these industry brokers, they have typically clustering capabilities, so that the broker doesn't is not like a single point of failure that can go down, and essentially both your publishers and subscribers are affected. One important thing in MQTT that we will see in our demo is topics. Topics are UTF-8 strings. The brokers use the topics to filter message for each connected client. So you will publish MQTT message to a particular topic, and you will subscribe to a particular topic in a Micronaut application. A topic contains of multiple levels, and they are separated by a forward slash, which we typically refer to as the delimiter. So here I have like a topic with 3 levels. An important thing to know is that topics are case sensitive. So these 2 topics are different topics, and the minimum number of characters of each topic is 1. And they are dynamic, so you don't have to know the topic in advance. You can create them dynamically. You can publish to a topic dynamically. So that's really flexible. You could use a wildcard for topics as well. So we have the single level wildcard. You see here the plus, where I could essentially say like this topic, my home ground floor plus temperature, will subscribe to both living room and kitchen, but it will not subscribe to kitchen brightness. It will not subscribe also, even if it has temperature, if it has another level for fridge. So you have like single level wildcard. Now we have also multi-level wildcard. With multi-level wildcard, the idea here is that you use the hash sign, and as you see, you can like you subscribe to the first leaf, but also to topics with 2 levels deep from the wildcard, but not for the first one. Some topic best practices use ASCII characters. Don't use any non-printable characters. Keep the topic shorter. Some people like to add the client ID into the topic name, and don't subscribe to hashtag like in the root, because that could lead like to a lot of messages. MQTT has also the concept of delivery of quality of service. We support that in Micronaut with a Vienna notation called at quality of service with the acronym. It has there are 3 levels in the spec. Level 0, when you essentially what is quality of service is the delivery guarantees between the communicating participants. So quality of service 0 means at most once delivery. Quality of service 1 means at least once delivery, and quality of service 2 means exactly once delivery. In terms of components, in an application, you will typically have a broker, an MQTT broker, and you will have MQTT clients. These are the yellow circles in this slide, where there will be clients publishing and subscriber MQTT events. You typically work with MQTT client libraries. The Micronaut implementation uses Paho, Eclipse Paho, which there is another great MQTT Java library, which is -q. We are not using that in Micronaut, but if the community has interest, it will be great to hear that interest is there to explore that. And you will typically need a broker. I'm going to be using in my demo Mosquito. There are other brokers that you can use. For example, -mq they have like a free broker, and they have like also like a kind of professional broker as well. And there are many more, but you will typically need to use those 2 pieces, client libraries and MQTT brokers. I have there are MQTT client libraries not just for Java, but for almost any programming language. But what I wanted to essentially point in this slide is that when you are working with Micronaut, you are going to working with Paho. I'm gonna I mentioned before that there are 2 MQTT versions, the 3.1 and the MQTT 5. We have 2 dependencies right now that you can, they have different Maven coordinates that you can use if you want to use either of those. I think in my demo I'm using MQTT 5 in both. But let me show you that. Let me show you the demo. And we can discuss it. So the demo I'm going to show you is already published as a guide. I have just increased the font, sorry about that. So if you go to Micronaut Launch, and go to launch.micronaut.io, which is the home to create Micronaut applications. You can always go to the Micronaut.io website, Micronaut.io website, and click here on launch a project, or if you go to resources, to download, here to launch in the menu. So you will find in the same place. We have in Micronaut Launch, we have this thing called features. The idea is that Micronaut Launch is going to generate a Micronaut project for you. As you know, Micronaut is build agnostic. You can select Gradle, Maven, or even Gradle with the Kotlin DSL. We support 3 programming languages, Java, Groovy, or Kotlin. And we support several testing frameworks as well. What I'm gonna do here is in features, the idea is that one important piece here is the application type. This is kind of the archetype of what you are trying to build. In my case, for the demo, I selected message-driven application. This is an application that doesn't even have an HTTP server running. By default, you will create an application that will have like an HTTP server running. But here I am just I only care to subscribe to an MQTT topic. You can come here and select MQTT, and this thing is adds support for MQTT messaging, and it adds support for MQTT messaging, the 3. So there are 2 different features. You can select it, and if I click here select it, you see that I included the feature. And if I click preview, you will see that what this does is this adds this dependency on my application, the Micronaut MQTT 5 dependency. It also modifies the application.yaml file, which is the application that it uses, and adds the configuration to connect to the MQTT broker, and it gives my client a random UID. So it gives me like a random client ID name. So what I did is I for my demo I created a message-driven application with the MQTT feature, and I click generate project. So if I go here and I click, if I open the project with IntelliJ IDEA, which I already had done, let me make the font bigger. So I have here the application with resources. As you saw, I have here the MQTT. This is the server, the MQTT broker direction, and the name of the client ID. I'm gonna run an MQTT broker on my computer. What I'm gonna use is I'm gonna be using Mosquito, which you can find at the mosquito.org with Mosquito with 2 T's. And if you say, it says Mosquito is an open source message broker that implements MQTT protocol versions 5.0, 3.1.1, and 3.1. It says Mosquito is lightweight and suitable for use on all devices from low power single board computers to full servers. What you will need to do is come here to your computer and click download. I will give you instructions for each client. If you see it has specific instructions for Raspberry Pi, because this is such a common scenario for people to run Mosquito in a Raspberry Pi. What I did is in my Mac I installed it via Homebrew. So I have here Mosquito in my computer, and I can run it here like this, and this essentially starts Mosquito on my Mac. And I am running Mosquito on port 1883, and it is not a coincidence that my application is pointing to localhost 1883, so I am pointing to my Mosquito server. And this thing has a temperature listener. This is a class that I annotated with MQTT subscriber. I have here a method annotated with a topic called house living room temperature. And as you saw, this is, if you remember, I kind of went with an example following the topic with the two delimiters. I am receiving a byte array of the message, and I am essentially taking the byte array and instantiating a big decimal, and I am logging temperature. By default, Micronaut will log the info level, so this thing, when we receive it, will appear in my logs. And one thing that you can do for test, if you want, is if you don't have like you want to test parts of your application where you don't have like an MQTT broker running, you can disable, for example, in a particular test with the MQTT enable property to false, and this will essentially allow you to run a test without a Mosquito, without attempting to connect to an MQTT broker. If you are interested on how to test this in the Micronaut MQTT project itself, we use test containers to test our MQTT integration. So that's a great place to see how you can actually create like a real test that has like I think we use like Mosquito to run it inside a test container. So check it out. What I'm gonna do is I'm gonna run the app. Nothing's gonna happen because we're gonna just subscribe to the topic, but no message is gonna be received. So I'm gonna come here to app. I could come and do let me try to generate a native image. So I could just run the app with Gradle run, but let me try to generate a native image, which is maybe is being too ambitious to generate a native image inside a Zoom call. So both Micronaut Maven plugin and the Micronaut Gradle plugin, they make generation of GraalVM native image seamless. The reason that I am showing how to generate a native image is because probably if you want to run these things on a Raspberry Pi, generating a native image is probably a good idea because they will essentially be like really low memory consumption applications. But I could also have generated a fat jar and just run with Java -jar, or here in development I could just have done Gradle run. So while the native image is being generated, which we are going to put here on the bottom left corner, I'm going to try to show you the CLI, the command line interface application. So I'm going to go to GitHub Micronaut project, Micronaut guides, build code, Micronaut MQTT Gradle Java, and I'm gonna show you the command line interface application that I wrote, which I really like writing command line applications with Micronaut. I think it's really science. So this support for writing command line application is powered by PicoCli. The website for PicoCli is picocli.info, and we are going to be actually using a couple of features from PicoCli, which I'm going to show you in a second. So I have a class here annotated with @command, and it has like a command name and a description, and it has two parameters. One is required and the other one is not required. One is the temperature and the other one is the scale. The temperature, the idea is that it's a number, and the scale, the idea is that it's either Celsius or Fahrenheit. And I have an enum to represent the scale, where it has Fahrenheit and Celsius. The enum doesn't have anything fancy, it just has one method to go from a string to enum, and if it is not able to, it returns an empty optional. I have one class which is used by PicoCli. This is a pattern where you have like a class that extends from array list string, and you can use it in the CLI application to show. So you see here completion candidates. Let me show you an example. So the Gradient native image of the Micronaut messaging application with subscribe has finished. Let me try to run it. So it says native image written to build native compile, build native compile Micronaut guide. So I am running the application. You saw here in the other terminal that a new client connected. This is the random client ID. I'm gonna go here to the CLI. I'm gonna actually run here. I'm gonna show you, like, I'm gonna generate a fat jar, and I'm gonna do java -jar build libs and all. This is, since I have only one command, this is gonna try. And you saw here how nice PicoCli is. It tells me, like, to use this command, you have these options. You have a scale, and it says, I have a typo, but let me correct that. Temperature scale. So thanks to the completion candidates, you can essentially show the probably I broke the test while doing that. Let me just run build without the test. So it tells temperature scale, Celsius or Fahrenheit, and temperature. So let me try to, the idea here is that I can, what is the Fahrenheit temperature of boiling water? That's 212 Fahrenheit. So the idea here is that I could do here a scale Fahrenheit, and I could do temperature 212, right? And what the idea of this application is that this is going to take this, is going to translate the Fahrenheit into Celsius, and it's going to publish as an MQTT message. So let me show you the code before I execute that. So we have this class with this a command application. The way my code will do is it will start a Micronaut application context. It will do like application context dot inject this, so that I am able to do here like field injection into this class. So I have here injected the temperature client, which I will show you in a second. Before doing that, when I execute the command, the run method is run. You see here that if I want to specify a scale, Celsius is used. And if I specify a scale, what I tend to do is go from a string to enum. And if I am not able, I still default to Celsius. I then have a method called Fahrenheit to Celsius, if the temperature scale is Fahrenheit, which transfer my big decimal from Fahrenheit to Celsius. So at the end of these two lines, I have my temperature in Celsius. I get the byte array, and I call a method in this client that I injected called publish living room temperature. And let me show you that method. This is an interface annotated with at MQTT publisher, and this interface is gonna be implemented by Micronaut for me, and I'm gonna publish an event to this topic. It is not a coincidence that this topic matches the topic that I am subscribed in the other application, so they are the same, right? So when I publish to this topic, I am gonna publish to the broker, and the broker is not gonna notify to all the subscribers. I could have multiple subscribers subscribe to this topic. And in order for the MQTT publishers to be available, I added to my CLI application the MQTT 5 dependency as well here. How can you create a CLI application in Micronaut? You go here and you do here in Micronaut Launch, you do a command line application. And that's what I did is command line application MQTT. And this will give you essentially a build file ready with a sample command. Right? And I have it here. I'm gonna execute the command line application. What I expect to happen is that I receive the equivalent of 200 Fahrenheit to Celsius, which is 100. So let's try this. Let's see if this works. So I just published, it told me quality of service 1, retain false. Quality of service 1 is the default. I sent the payload of 100, so I transformed the Fahrenheit to Celsius, and I published to the broker the Celsius, and you saw that I received it in the listener. So pretty seamless to publish a topic and receive in the other listener. If I go to the CLI, I'm gonna show you the test. So I have a test here, and this is something that I wanted to show you. For the test, I am starting the application context here directly in the test, so I'm not using the @Micronaut test annotation, but I am starting the application context here. And as you see, I am disabling the MQTT enable false, same as we did in the other application. And I am doing a pattern, which is, you will see in almost every Micronaut module, which is the pattern of a spec name. In order to avoid beam pollution, you could have like a replacement in the test. So I am replacing the temperature client just for this test, because this beam will be only loaded if this property is present, and this property is present only in this test. And what I am testing is that instead of publishing to the broker, what I am doing is just saving here in this list of byte arrays. So I can verify the whole logic of, with this test, I can verify that all this logic of this private method and all this logic is working correctly, right? I'm just mocking this published living room temperature. And this is, I think, a great way of illustrating that. And that's the demo. I have published the demo today to guides.micronaut.io here in publishing and subscribing to MQTT Topics for a Micronaut application. You can find the instructions to generate both applications, link to Mosquito, explanations about the different parts of the code that I may have missed during the presentation, and hopefully this will inspire you to play a little bit with Micronaut and MQTT. The Micronaut MQTT module has a couple of things more. It has not just the Micronaut MQTT publisher and the MQTT subscriber annotation. It has also health checks. It has an annotation called MQTT property, which you can use both in publishers and subscribers. The topic annotation, you saw it already. The quality of service. Let me show you that. Let me see if we can actually leverage that. So in Micronaut, the home of all the documentation, if you go to docs.micronaut.io or you go directly from the website to learn user documentation, this is the documentation for the main modules, and if you scroll down, you will find all the documentation from the different modules. If you search here for MQTT, you will find the links to the micro documentation. Key here in all the micro documentation is we have the Java documentation, but we have another important bit, which is configuration reference. Here you're gonna find this configuration comes from our source code, so this configuration is correct. This is not like a table that we are maintaining and that may get out of sync. This is always sync, and you have, for example, documentation about how to disable MQTT enable, and you have also documentation about, for example, how to supply a client password and username if you need to authenticate, and many settings. Sometimes in some modules we reference the documentation as we do here, as well. So all of this documentation is the same as you found it in documentation reference. We just have the ability to embed those snippets. For the quality of service, it says quality of service can be set for publishing either through topic or the QoS annotation. So I could do here, in theory, if I understand correctly, I could publish my message with a different quality of service. You saw that by default it was 1, but I could come here and do in the temperature client, I could do here, this takes an int, which will be, I could say 2, or I could even say, like, I think I could do like with the annotation, these annotations takes these annotations should not be used on subscriber classes or methods that again per topic use. Let me write here 2. Let me try to generate here another fat jar. Let's try and let's see if we published actually with quality of service 2 now. There you go. And we received it here as well. You saw me publishing a byte array. You can also like this is important regarding the payload. So the library supports most standard Java types and JSON serialization using Jackson, but you can also add your own serialization strategies, and we have a section in the documentation describing that. So please check it out. This should be quite flexible. And I think that's more or less cover everything that I wanted to cover, Jen. I just wanted to show a demo of Micronaut MQTT, and hopefully we can get some feedback from the community in terms of what do they think we are missing and what they would like to see for Micronaut MQTT going forward.